The T-72 is a Soviet second-generation main battle tank that entered production in 1971. About 20,000 T-72 tanks were built, making it one of the most widely produced post-World War II tanks, second only to the T-54/55 family. The T-72 was widely exported and saw service in 40 countries and in numerous conflicts. Development. T-64. The development of the T-72 was a direct result of the introduction of the T-64 tank. The T-64, Object 432, was a very ambitious project to build a competitive well-armored tank with a weight of not more than 36 tons. Under the direction of Alexander Morozov in Kharkov, a new design emerged with the hull reduced to the minimum size possible. To do this, the crew was reduced to 3 soldiers, removing the loader by introducing an automated loading system. The much smaller design presented a problem when selecting a suitable engine. This led to the introduction of the 700 HP 5 TDF engine, which was unreliable, difficult to repair, and had a guaranteed lifespan similar to World War II designs. Production of the T-64 with a 115 mm gun began in 1964. Plans for an upgun T-64A with a more powerful 125 mm gun had already been made in 1963. Problems with the early production run were evident from the start, but a strong lobby formed around Morozov, who advocated for the T-64 in Moscow, preventing rival developments and ideas from being discussed. Mobilization model. Because of the time-consuming construction of the 5 TDF engines, which took about twice as long as the contemporary V-45, the Malyshev factory in Kharkov could not provide a sufficient number of 5 TDF engines for all Soviet tank factories. This led to efforts at Uralvagonzavod to design a version of the T-64 with the cheaper and much more reliable V-45 engine of 780 HP. This model was only to be serially produced in the event of a war, a so-called mobilization model. In 1967, the Uralvagonzavod formed Section 520, which was to prepare the serial production of the T-64 for 1970. The team soon found out that the more powerful V-45 engine put a lot of stress on the T-64 hull, so that after some time cracks started to materialize. A more stable solution was sought. Finally, an idea from 1960 was used. When a modification of the T-62 had been discussed, in 1961, 2 prototypes of Object 167 had been built by Uralvagonzavod to test a stronger hull and running gear combination for that tank. Under influence from Kharkov, the idea had been turned down by Moscow. But this construction, with its big, rubber-coated road wheels, now formed the basis for the mobilization model of the T-64. Additional changes were made to the automatic loading system, which also was taken from an earlier project, originally intended for a T-62 upgrade. The 125 mm ammunition, consisting of a separate projectile and a propellant charge, was now stored horizontally on 2 levels, not vertically on 1 level as in the T-64. It was said to be more reliable than the T-64 autoloader. In 1964, 2 125 mm guns of the D-81 type had been used to evaluate their installation into the T-62, so the Ural plant was ready to adopt the 125 mm caliber for the T-64A as well. T-72. Uralvagonzavod produced the first prototype with a 125 mm gun and V-45K engine in 1968 as Object 172. After intensive comparative testing with the T-64A, Object 172 was re-engineered in 1970 to deal with some minor problems. However, being only a mobilization model, serial production of Object 172 was not possible in peacetime. In an unclear political process, Decree No. 326/113 was issued, which allowed the production of Object 172 in the Soviet Union from January 1, 1972, and freed Uralvagonzavod from the T-64A production. The first batch was built as Object 172M and, after some modifications, it was tested again in 1973 and accepted into service as the T-72 under Soviet Ministry Directive No. 554-172 dated August 7, 1973. At least some technical documentation on the T-72 is known to have been passed to the CIA by the Polish Colonel Ryszard Kuklinski between 1971 and 1982. Production history. The first series production of T-72 Object 172M began in July at UKBM Nizhny Tagil. However, due to difficulties in getting the factory organized for the change in production from T-64 to T-72, only 30 completed tanks were delivered in 1973. Troubles continued in 1974 where out of a state production quota of 440 only 220 were officially declared, with the actual number of completed tanks being close to 150. As a result, substantial investment in tooling was undertaken. Only after modernization could the factory begin full-scale production of the T-72. Nizhny Tagil produced the tank in various modifications until 1992. The T-72 was the most common tank used by the Warsaw Pact from the 1970s until the collapse of the Soviet Union in 1991. It was also exported to other countries, such as Finland, India, Iran, Iraq, Syria, and Yugoslavia, as well as being copied elsewhere, both with and without licenses. Licensed versions of the T-72 were made in Poland and Czechoslovakia, for Warsaw Pact consumers. These tanks had better and more consistent quality of make but with inferior armor, lacking the resin-embedded ceramics layer inside the turret front and glassy armor, replaced with all steel. The Polish-made T-72G tanks also had thinner armor compared to Soviet Army standard, 410 mm for turret. Before 1990, Soviet-made T-72 export versions were similarly downgraded for non-Warsaw Pact customers, mostly the Arab countries. Many parts and tools are not interchangeable between the Russian, Polish, and Czechoslovakian versions, which caused logistical problems. Yugoslavia developed the T-72 into the more advanced M84, and sold hundreds of them around the world during the 1980s. The Iraqis called their T-72 copies the Lion of Babylon, Asad Babil. These Iraqi tanks were assembled from kits sold to them by Russia as a means of evading the unimposed weapons embargo. More modern derivatives include the Polish PT-91 Twardy. Several countries, including Russia and Ukraine, also offer modernization packages for older T-72s. Various versions of the T-72 have been in production for decades, and the specifications for its armor have changed considerably. Original T-72 tanks had homogeneous cast steel armor incorporating spaced armor technology and were moderately well protected by the standards of the early 1970s. In 1979, the Soviets began building T-72 modification with composite armor similar to the T-64 composite armor, in the front of the turret and the front of the hull. Late in the 1980s, T-72 tanks in Soviet inventory, and many of those elsewhere in the world as well, were fitted with reactive armor tiles. Laser rangefinders have appeared in T-72 tanks since 1978. Earlier examples were equipped with parallax optical rangefinders, which could not be used for distances under 1,000 meters, 1,100 yd. Some export versions of the T-72 lacked the laser rangefinder until 1985 or sometimes only the squadron and platoon commander tanks, version K, received them. After 1985, all newly made T-72s came with reactive armor as standard, the more powerful 840 bhp, 630 kilowatts, V-84 engine and an upgraded design main gun, which can fire guided anti-tank missiles from the barrel. With these developments, the T-72 eventually became almost as powerful as the more expensive T-80 tank, but few of these late variants reached the economically ailing Warsaw Pact allies and foreign customers before the Soviet bloc fell apart in 1990. Since 2000, export vehicles have been offered with thermal imaging night vision gear of French manufacture as well, though it may be more likely that they might simply use the locally manufactured Buran Catharin system, which incorporates a French thermal imager. Depleted uranium armor-piercing ammunition for the 125 mm, 4.9 in, gun has been manufactured in Russia in the form of the BM-32 projectile since around 1978, though it has never been deployed, and is less penetrating than the later tungsten BM-42 and the newer BM-42M. Models. Main models of the T-72, built in the Soviet Union and Russia. Command tanks have K added to their designation for Komandersky, command. For example, T-72K is the command version of the basic T-72. Versions with reactive armor have V added, for V's Rivnois, explosive. T-72 Ural, 1973. Original version, armed with 125 mm smoothbore tank gun and optical coincidence rangefinder. T-72A, 1979. Added laser rangefinder and electronic fire control, turret front and top being heavily reinforced with composite armor, nicknamed Dolly Parton by U.S. intelligence, provisions for mounting reactive armor, smoke grenade launchers, flipper armor mount on front mudguards, internal changes. T-72M. Export version, similar to T-72A. Also built in Poland and former Czechoslovakia. T-72B, 1985. New main gun, stabilizer, sights, and fire control, capable of firing 9 M119 SVR guided missile, additional armor including 20 mm, 0.8 in, of applique armor in the front of hull, improved 840 HP, 630 kilowatts, engine. T-72B3, 2010, T-72B3M, 2017. Uses 9M119M missile, new main gun and fire control, aiming of T-90, new ammo, improved 1130 HP, 840 kilowatts, engine, more than 1000 PCS. T-72B3M, many important changes. Uses relict era. The T-72 design has been further developed into the following new models: Lion of Babylon tank, Iraq, M84, Yugoslavia, M95 Degman, Croatia, M2001, Serbia, PT9120, Poland, Tank X, India, and TR125, Romania. Variants. The T-72 hull has been used as the basis for other heavy vehicle designs, including the following: BMPT Heavy Convoy Enclosed Tank Support Vehicle, TOS-1 Thermobaric Rocket Launcher, with 30-tube launcher in place of the turret. BREM-1, Bronirovane a Rimonto Evacuazione a Macchina, Armored Recovery Vehicle with a 12-ton crane, 25-ton winch, dozer blade, towing equipment, and tools. IMR-2, Inženjerna Mašina Razgrištenia, Combat Engineering Vehicle with an 11-ton telescoping crane and pincers, configurable dozer blade/plow, and mine clearing system. MTU-72, Tankovi Stukladkik, Armored Bridge Layer, capable of laying a 50 tons, 55 short tons, capacity bridge spanning 18 m, 59 feet, in 3 minutes. BMR-3, Bronirovanagia Mašina Razminirovanija, Mine Clearing Vehicle. Remote Weapon Stations. Odin 57 RCWS is a remote weapon station using Bofors 57mm gun developed by Valhalla. Design characteristics. The T-72 shares many design features with other tank designs of Soviet origin. Some of these are viewed as deficiencies in a straight comparison to NATO tanks, but most are a product of the way these tanks were envisioned to be employed, based on the Soviets' practical experiences in World War II. Weight. The T-72 is extremely lightweight, at 41 tons, and very small compared to Western main battle tanks. Some of the roads and bridges in former Warsaw Pact countries were designed such that T-72s can travel along in formation, but NATO tanks could not pass at all, or just one by one, significantly reducing their mobility. The basic T-72 is relatively underpowered, with a 780 HP, 580 kilowatts, supercharged version of the basic 500 HP, 370 kilowatts, V12 diesel engine originally designed for the World War II era T-34. The 0.58 m, 1 foot 11 in, wide tracks run on large diameter road wheels, which allows for easy identification of the T-72 and descendants. The T-64/80 family has relatively small road wheels. The T-72 is designed to cross rivers up to 5 m, 16.4 feet, deep submerged using a small diameter snorkel assembled on site. The crew is individually supplied with simple rebreather chest pack apparatuses for emergency situations. If the engine stops underwater, it must be restarted within 6 seconds, or the T-72's engine compartment becomes flooded due to pressure loss. The snorkeling procedure is considered dangerous, but is important for maintaining operational mobility. Nuclear, biological, and chemical protection. The T-72 has a comprehensive nuclear, biological, and chemical, NBC, protection system. The inside of both hull and turret is lined with a synthetic fabric made of boron compound, meant to reduce the penetrating radiation from neutron bomb explosions. The crew is supplied clean air via an extensive air filter system. A slight overpressure prevents entry of contamination via bearings and joints. Use of an auto-loader for the main gun allows for more efficient forced smoke removal compared to traditional manually loaded, pig loader, tank guns, so NBC isolation of the fighting compartment can, in theory, be maintained indefinitely. Exported T-72s do not have the anti-radiation lining. Interior. Like all Soviet legacy tanks, the T-72's design has traded off interior space in return for a very small silhouette and efficient use of armor, to the point of replacing the fourth crewman with a mechanical loader. The basic T-72 design has extremely small periscope viewports, even by the constrained standards of battle tanks, and the driver's field of vision is significantly reduced when his hatch is closed. The steering system is a traditional dual-tiller layout instead of the easier-to-use steering wheel or steering yoke common in modern Western tanks. This setup requires the near-constant use of both hands, which complicates employment of the 7-speed manual transmission. There is a widespread Cold War-era myth that T-72 and other Soviet tanks are so cramped that the small interior demands the use of shorter crewmen, with the maximum height set at 1.6 m, 5 feet 3 in the Soviet Army. According to official regulations, however, the actual figure is 1.75 m, 5 feet 9 in. Armor. Armor protection of the T-72 was strengthened with each succeeding generation. The original T-72 Ural Object 172 ms, from 1973, turret is made from conventional cast HHS steel armor with no laminate inserts. It is believed that the maximum thickness is 280 mm, 11 in, and the nose is 80 mm, 3.1 in. The glacis of the new laminated armor is 205 mm, 8.1 in, thick, comprising 80 mm, 3.1 in, HHS steel, 105 mm, 4.1 in, double layer of laminate, and 30 mm, 1.2 in, RHA steel, which when inclined gives about 500-600 mm, 20-24 in, thickness along the line of sight. In 1977 the armor of the T-72 Object 172M was slightly changed. The turret now featured insert filled with ceramic sandbars, quartz rods, and the glacis place composition was changed. It was now made up of 60 mm, 2.4 in, HHA steel 105 mm, 4.1 in, glass textilate laminate, and 50 mm, 2.0 in, RHA steel. This version was often known in Soviet circles as T-72 Ural 1. The next armor update was introduced by the T-72A, Object 176, which was designed in 1976 and replaced the original on the production lines during 1979 to 1985. T-72 Object 1976 is also known as T-72A. With the introduction of the T-72B, Object 184, in 1985, the composite armor was again changed. According to retired Major James M. Warford, variants developed after the T-72 base model and T-72M/T-72 GMBT, featured a cast steel turret that included a cavity filled with quartz or sand in a form similar to U.S. fused silica armor. Stephen J. Zalaga mentions that the T-72 model 1978, Obianite 172 MSB4, which entered production in 1977, featured a new turret with special armor composed of ceramic rods. The T-72A featured a new turret with thicker, nearly vertical, frontal armor. Due to its appearance, it was unofficially nicknamed Dolly Parton armor by the U.S. Army. This used the new ceramic rod turret filler, incorporated improved glassy laminate armor, and mounted new anti-shaped charge side skirts. The T-72M was identical to the base T-72 Ural model in terms of protection, retaining the monolithic steel turret. The modernized T-72M1 was closer to the T-72A in terms of protection. It featured an additional 16 mm (0.63 in) of high-hardness steel applique armor on the glassy plate, which produced an increase of 43 mm (1.7 in line-of-sight thickness. It was also the first export variant with composite armor in the turret, containing ceramic rods sometimes called sandbar armor. The turret armor composition was essentially identical to the T-72 Ural one, whereas Soviet-only T-72s had slightly increased turret protection. Several T-72 models featured explosive reactive armor, ERA, which increased protection primarily against heat-type weapons. Certain late-model T-72 tanks featured heavy ERA to help defeat modern heat and AP against which they were insufficiently protected. Late-model T-72s, such as the T-72B, featured improved turret armor, visibly bulging the turret front, nicknamed Super Dolly Parton armor by Western intelligence. The turret armor of the T-72B was the thickest and most effective of all Soviet tank armor. It was even thicker than the frontal armor of the T-80B. The T-72B used a new reflecting plate armor, Brynia s Otrazayushchimi Listami, in which the frontal cavity of the cast turret was filled with a laminate of alternating steel and non-metallic, rubber, layers. The glacis was also fitted with 20 mm (0.8 in) of applique armor. The late production versions of the T-72B/B1 and T-72A variants also featured an anti-radiation layer on the hull roof. Early model T-72s did not feature side skirts. Instead, the original base model featured gill or flipper-type armor panels on either side of the forward part of the hull. When the T-72A was introduced in 1979, it was the first model to feature the plastic side skirts covering the upper part of the suspension, with separate panels protecting the side of the fuel and stowage panniers. The July 1997 issue of Jane's International Defense Review confirmed that after the collapse of the USSR, US and German analysts had a chance to examine Soviet-made T-72 tanks equipped with Contact 5 era, and they proved impenetrable to most modern US and German tank projectiles. A US Army spokesperson claimed at the show, "The myth of Soviet inferiority in this sector of arms production that has been perpetuated by the failure of downgraded T-72 export tanks in the Gulf Wars has, finally, been laid to rest." The results of these tests show that if a NATO/Warsaw Pact confrontation had erupted in Europe, the Soviets would have had parity, or perhaps even superiority, in armor. K-effective era, such as Contact 5, drove the development of M829A3 ammunition. Late 1980s, Soviet developed Object 187, or T-72B. It was a parallel project to Object 188. The T-90 tank. It was based on the T-72B, with a heavily modified turret. The Object 187 used composite armor for the turret, Super Dolly Parton composite armor, and the hull front, and RHA for the rest of the tank. It possibly consisted of special materials including ceramic or high-density uranium alloys. Maximum physical thickness of the passive armor, not counting the reactive armor, ERA, was up to 950 mm RHA. With Contact 5 era, T-72's frontal armor was immune to the NATO's 120mm L/44 tank gun. However, after the Soviet collapse, the tank was not accepted. Estimated protection level. The following table shows the estimated protection level of different T-72 models enrolled homogeneous armor equivalency. i.e., the composite armor of the turret of a T-72B offers as much protection against an APFS round as a 520mm, 20 in, thick armor steel layer. Possible easy replacement of contact 5, or 1, with relict. Relict defends against tandem warheads and reduces penetration of APFS rounds by over 50%. Calculation T-72B and relict vs APFS, on turret 1,0001,050 mm, on hull 950 to 1000 mm. For T-90MS relict is a basic set, for the T-90S basic set contact 5. The calculation for A** vs heat* is more complicated. Gun. The T-72 is equipped with the 125mm, 4.9 in, 2A46 series main gun, a significantly larger, 20 mm larger, caliber than the standard 105mm, 4.1 in, gun found in contemporary Western MBTs, and still slightly larger than the 120mm/L44 found in many modern Western MBTs. As is typical of Soviet tanks, the gun is capable of firing anti-tank guided missiles, as well as standard main gun ammunition, including heat and APFS rounds. The original T-72 Object 172M, 1973, used 2A26M2 model gun first mounted on T-64. The barrel had a length of 6,350 mm or 50.8 calibers and had maximum rated chamber pressure of 450 MPa. The cannon had an electroplated chrome lining but lacked a thermal sleeve. The cannon was capable of firing 3 VBM-3 round with 3 BM-9 steel projectile sabot and 3 VBM-6 round with 3 BM-12 tungsten sabot APFS projectile, allowing respectively 245 mm, 9.6 in, and 280 mm, 11 in, penetration of RHA steel at 2000 at 0 degree angle. In addition to APFS rounds, T-72 Object 172M could also fire 3 VBK-7 round incorporating 3 BK-12 heat warhead and 3 VBK-10 round incorporating 3 BK-14 heat warhead. Heat rounds allowed respectively 420 mm, 17 in, and 450 mm, 18 in, penetration of RHA steel at 0 degree angle. The high explosive rounds provided included 3 WOF-22 with 3 of 19 warhead or 3 WOF-36 with the 3 of 26 warhead. For all rounds, the ZH-40 propellant was used. Complementing the original gun setup was 2 E-28M Siren 2-plane electro-hydraulic stabilizer allowing automatic stabilization with speeds from 0.05 to 6 degrees per second. Even as the T-72 Object 172M, 1973, was entering production, new ammunition was developed to offset armor developments in the West. Beginning in 1972, 2 new APFS rounds were introduced, the 3 VBM-7 round with 3 BM-15 tungsten sabot projectile and the cheaper 3 VBM-8 round with 3 BM-17 sabot but without the tungsten carbide plug. These allowed penetration of respectively 310 mm, 12 in, and 290 mm, 11 in, RHA steel at 2000 at 0 degree angle. At the same time, a universal ZH-52 propellant charge was introduced. The 3 VBM-7 was the most common APFS round found in T-72 Object 172M tanks during the 70s. The stated barrel life expectancy of the 2A26M2 model gun was 600 rounds of He/heat equivalent to 600 EFC, effective full charge, or 150 rounds of APFS. The main gun of the T-72 has a mean error of 1 m, 39.4 in, at a range of 1800 m, 1968.5 yd. Its maximum firing distance is 3000 m, 3280.8 yd, due to limited positive elevation. The limit of aimed fire is 4000 m, 4374.5 yd, with the gun-launched anti-tank guided missile, which is rarely used outside the former USSR. The T-72's main gun is fitted with an integral pressure reserve drum, which assists in rapid smoke evacuation from the bore after firing. The 125 mm gun barrel is certified strong enough to ram the tank through 40 cm of iron-reinforced brick wall, though doing so will negatively affect the gun's accuracy when subsequently fired. Rumors in NATO armies of the late Cold War claimed that the tremendous recoil of the huge 125 mm gun could damage the fully mechanical transmission of the T-72. The tank commander reputedly had to order firing by repeating his command, "When the T-72 is on the move, fire! Fire!" The first shout supposedly allowed the driver to disengage the clutch to prevent wrecking the transmission when the gunner fired the cannon on the second order. In reality, this still common tactic substantively improves the tank's firing accuracy and has nothing to do with recoil or mechanical damage to anything. This might have to do with the lower quality, compared to Western tanks, of the T-72's stabilizers. The vast majority of T-72s do not have FLIR thermal imaging sights, though all T-72s, even those exported to the Third World, possess the characteristic, and inferior, Luna infrared illuminator. Thermal imaging sights are extremely expensive, and the new Russian FLIR system, the Buran-Katharin thermal imaging suite, was introduced only recently on the T-80 tank. Most T-72s found outside the former Soviet Union do not have laser rangefinders. T-72s built for export have a downgraded fire control system. Autoloader. Like the earlier domestic use-only T-64, the T-72 is equipped with an automatic loading system, eliminating the need for a dedicated crew member, decreasing the size and weight of the tank. However, the autoloader is of a noticeably different design. Both the T-64 and T-72 carry their two-section 125 mm ammunition, shell and full propellant charge or missile and reduced propellant charge, in separate loading trays positioned on top of each other, but firstly, in T-64, 28 of these were arranged vertically as a ring under the turret ring proper, and were rotated to put the correct tray into position under the hoist system in the turret rear. This had the disadvantage of cutting the turret off from the rest of the tank, most notably, the driver. Accessing the hull required partial removal of the trays. The T-72 uses a design that has lower width requirements and does not isolate the turret compartment. The trays are arranged in a circle at the very bottom of the fighting compartment. The trade-off is the reduction of the number of trays to 22. The second difference is that in the T-64 the trays were hinged together and were flipped open as they were brought into position, allowing both the shell/missile and propellant charge to be rammed into the breech in one motion. In the T-72 the tray is brought to the breech as is, with the shell in the lower slot and the charge in the upper one, and the mechanical rammer sequentially loads each of them, resulting in a longer reloading cycle. The autoloader has a minimum cycle of 6.5 seconds, ATGM 8 seconds, and a maximum cycle of 15 seconds for reload. In later versions the sequence mode allows to reload in less than 5 seconds, allowing to reach 3 shots in 13 seconds. The autoloader system also includes an automated casing removal mechanism that ejects the propellant case through an opening port in the back of the turret during the following reload cycle. The autoloader disconnects the gun from the vertical stabilizer and cranks it up 3 degrees above the horizontal in order to depress the breech end of the gun and line it up with the loading tray and rammer. While loading, the gunner can still aim because he has a vertically independent sight. With a laser rangefinder and ballistic computer, final aiming takes at least another 3 to 5 seconds, but it is pipelined into the last steps of auto-loading and proceeds concurrently. In addition to the 22 auto-loaded rounds, the T-72 carries 17 rounds conventionally in the hull, which can be loaded into the emptied auto-loader trays or directly into the gun slowly and awkwardly due to the absence of a human loader. Service. The T-72 was never used in the Afghanistan War. The 40th Soviet Army that was deployed there had only T-55 and T-62 tanks. The Russian Federation has over 5,000 T-72 tanks in use, including around 2,000 in active service and 3,000 in reserve. The T-72 has been used by the Russian army in the fighting during the First and Second Chechen Wars and the Russo-Georgian War. The T-72 has been used by over 40 countries worldwide. Syria. In the 1982 Lebanon War, Syrian T-72s engaged Israeli M60A1, Magach, and probably Merkava tanks in the south of Lebanon. The most reliable version, T-72 never met the Merkava in battle. On June 9, 1982, the Syrian General HQ ordered a brigade of the 1st Armored Division, equipped with T-72 tanks, to move straight ahead, cross the border, and hit the right flank of the Israeli units advancing along the eastern side of Bekaa, destroying some Israeli companies. After the war, the Syrian President Hafez al-Assad called it the best tank in the world. The T-72 has been in extensive use in the Syrian civil war by the Syrian Arab Army since 2011, and quite a few captured examples are used by the anti-government Free Syrian Army rebels and jihadists groups such as the Islamic Front and the Islamic State of Iraq and Syria. Throughout the Syrian civil war, government forces have used T-72s, among other armored vehicles, against the opposition forces. Initially, the insurgent forces were forced to use IEDs and RPG-7 ambush tactics against the government armored forces. Later, modern Russian RPGs and Yugoslav M79 were recorded in rebel hands and being used to achieve successful hits on T-72s. Starting in 2012, the capture from Syrian stocks and later direct delivery by external sponsors of modern anti-tank guided missiles, including Chinese-made HJ-8, Soviet-made 9K111 Fagot, 9M113 Concours, and 9K115 Métis and American-made TOW enabled the opposition forces to successfully engage and destroy any government armored vehicle types, T-72 included, from safer distances. Iraq. At the beginning of the Iran-Iraq War, an Iraqi tank battalion, equipped with T-72s, in a battle near the town of Kasri Shirin completely defeated an Iranian tank battalion which consisted of chieftain tanks, without incurring losses. Iranian M47 Patton tanks suffered losses during clashes with Iraqi T-62s and T-72s. A large number of Iranian M47 tanks were captured by Iraq. The Iraqi-assembled T-72 version Lion of Babylon engaged coalition forces in both Iraq wars. Battle of 73 Easting took place during a sandstorm in the Iraqi desert. American M1A1s and Bradley fighting vehicles came up against Iraqi Republican Guard T-72s and BMPs and inflicted 37 T-72 losses on the Iraqi armored forces while losing a single Bradley to enemy fire. The primary battle was conducted by two ACRS-3 squadrons of about 400 soldiers, along with the 1st Infantry Division's two leading brigades, who attacked and destroyed the Iraqi 18th Mechanized Brigade and 37th Armored Brigade of the Tawakalna Division, each consisting of between 2,500 and 3,000 personnel. On February 26, 1991, the Iraqis used dug-in T-72 tanks T.
Please subscribe and thanks for watching.